Okay, I'm going to be talking about repeating fractions today. The first example, the smallest example, would be 1/7. Alright, 1/7 is 0.142857, 142857, 142857. So as you can see, it repeats this, okay? So now let's look at 2/7. 2/7. That is 0.285714, So if you notice something here, this one also repeats, but not only does it also repeat, it's also 4285714285714, which was our original. Our original was 142857. Here it is, 142857, 142857. So it just starts a little bit earlier on. This one's, let's see, it starts on the 2. So 0.285714. Alright, and the same thing happens with 3/7, 4/7, 5/7, and 6/7. So let me just write out the number those start on. Go to 3/7. It starts on a 4. Alright, so that'd be this 4. So it would go 42857 and 42857. There we go. Let's go to 4/7. Starts on the 5. So because it starts on the 5, it'd be 571428. 571428. See, 571428, 571428. And then the 5 starts on the 7, and the 6 starts on the 8. Okay, so we run through this pattern, and let's just try and declare something real quick. We'll say 1/7 is the standard bar. So when we go to 2/7 and we're starting here, we're not starting on the first one, we're starting on the second, the third one, right? So actually, let's make it the 0. Alright, this time we start on the 0th one, so 1 would be the first one, 4 would be the second one. I'm sorry, 1 would be the 0th one, 4 is the first, and 2 is the second. So this time we start on the second one, and then this time we start on the first one. This one is the fourth one, 5. So 4/7, we start on the fourth one, right? That's the 5, and then 7, which is 5/7. So that's the fifth one, and 8 is the third one. So it goes 0, 2, 1, 4, 5, 3, or we could make it say 1, 3, and we're starting on 1 instead of 0. 1, 3, 2, 5, 6, 4. All I did was simply add 1 to each one. Okay, so 1/7 is 1, 2 is 3, 3 is 2, 4 is 5, 5 is 6, and 6 is 4. So 1, 3, 2, 5, 6, 4 is our pattern. Alright. I feel like I discovered this pattern along with many of my pattern videos you'll be seeing. I discovered this pattern a long time ago, and I feel like I had some way of determining why it was this order, but for now I can't remember it, so I'll just move on. But one other thing is that there's 6 digits that repeat, and this is 1/7. Alright, so the number we're dividing by is 7, and there are 6 digits that repeat. So 1/7 is our first number, and there's 6 digits that repeat. Alright, and then the next one I believe is, I think the next one is 1/13, if my memory doesn't mistake me. Let's see, 1/13. But there was something interesting about this one. Let's see if I can remember. Alright, 07692307692307. Alright, so that one works. And I think it was that it changed. I think with 1/13 it switched over halfway through, but we'll see. So 1/13 gives us 076923. Hold on. So that gets repeated, and that is also 6 digits that get repeated. And then 2/13 was, oh yeah, okay, so 13 it alternates. Actually, I don't think it alternates 1 on 1, but there is a pattern to the alternation. So 153846, 153846, 153846. So 153846. And then 3, 4. Let me go ahead and type all these out. Let me make this smaller also. Let's see. Is it? No? How do I do this? Okay. Make this text smaller so it'll fit. Alright. Also, I don't know why I have a space background. I was doodling before I started this video, so there's stars and this cloud, if you're wondering. Alright, 3/13. 230769, 230769. So it's this one. It's this one now, and it's starting with the 2-3. So 0.23079. Let's go down. 4/13. 30769. So this is also the 230769. We're starting on the 3 this time. So let's go 0.307692. And then 5/13. This one should go back. Alright, so now we're on the other pattern that was repeating. We start on the 3846. So 0.3846, 384615, and 6/13. Let's see, 4. So we're on the 384615 again. We start on the 4. 0.461538. Now 7/13. Right. This one should go back, I think. No, we're still on the 384615. Starts on the 5. So let's see. 0.538461. So you can see how these are, like here we have 538 and then 461. Like if this was repeating, like it will be in the real answer. Here we have the, I'm just writing out the repeating part. We got a 538461. Here it is, 538461. So it's just starting later on in the number. 8/13. This one goes back to this pattern, I believe. It's been a long time since I've messed with these numbers. 6-1. I know, we're still on the 384615, so on the 6. 6-1-5-3-8-4. 9/13. This one's got to go back over. Yeah, it does. 692. Alright. 0.692307. 10/13. This one should stay on that one, right? 769. Okay. 769. Where am I? 769,230. 11/13. 8-4. So we're back on that second pattern. 6-1-5-3. And last but not least, 12/13. 0.92307. So we're on the first one. 0.92376. All right. So our next one that this repeating fraction pattern works for is 1/13. And this has, it looks like it has 6. There's 6 digits that repeat, but there's actually 2 different sets of these 6 digits that repeat. So there's 12. 6 plus 6 is 12, right? So you'll start to see a pattern up here. On 1/7 there was 6 that repeat. On 1/13 there's 12 that repeat. And I've checked this. I think I went up in the 20s, like 1/27 or something like that. And it's always one less than. You may have 2 sets, and there's some more that only have 1 set, but it's always one less than. So 1/7 has 6, which is 1 less than 7. 1/13 has 12 repeating digits in its repeating pattern. It's those 6 and those 6 make 12. And that's 1 less than 13. And the pattern you'll see here is there's two bar sets. There's this bar set and there's this bar set, and we alternate between them on a pattern. So I'll put a blue for this one, right? And I'll put red for this one. So it goes 1 1 2 4 2 1 1. If you look, you'll notice it's mirrored. If I take these colors, the first 6, and this works with every time we alternate through them. It's this pattern of 1s to 2s to 4s, you know. So I'll take this first set, I'll drag it over here, and I'll flip it upside down, right? And you'll see that it is the same as the bottom. It's the same: red, red, blue, blue, red, blue. So there is a pattern to which number set we alternate between. And I think the next fraction is, I might be mistaken because it's been a while since I've done this, but I think the next fraction this works for is 1/17. Anyways, I'd like to get a list, maybe I'll do this in the future, of the fractions this works for up to 1/99 or whatever it is. Maybe there'd be a cool pattern in the series of it, like 1/7 to 1/13 to 1/17 or whatever it is. Maybe those numbers have something in common. But it is cool to know these patterns in division, that these repeat like this. Special fractions that repeat on the number of digits 1 less than that number, like 1/7 that repeats after 6 digits. 6 is 1 less than 7. It's cool to know those. And I think there was one last thing I discovered. I think they always added up to 9. Let me take the sum of these digits real quick, because I'm not completely sure. But maybe I just imagined that, but I thought that was, so 7 plus 6 plus 9 plus 2 plus 3 is 27, and 2 plus 7 is 9. 1 plus 5 plus 3 plus 8 plus 4 plus 6 is 27. 2 plus 7 is 9. Alright, and then let's go to 1/7. 1/7 is 142857. 142857 before it repeats. Let's add that. 1 plus 4 plus 2 plus 8 plus 5 plus 7 is 27. 2 plus 7 is 9. So yeah, these, if I'm not mistaken, these always add up to 9. The parts that repeat, when you add them together, the separate digits, they add up to 9 eventually. I'm not saying this adds to 9, this adds to 27, but then when you have the 27, the 2 plus the 7 adds up to 9. And interestingly enough, these also added up to 27, so I'm wondering if they all add up to 27 and then therefore 9. But for now, that's the end of this video. If I ever decide to continue this research for this part, which I probably will, because this fascinates me, I'll post a list. You'll probably see a link somewhere over here, maybe down here, I don't know, but a link to another page that has a list of the fractions and maybe the numbers that make them up, and I'll see if all the sums are 27, and then add to 9. That'd be a cool thing to learn. But I hope this intrigued you. I hope you learned a lot. It's pretty fascinating to me. So if you have any questions, any comments, feel free to email me. Here's my email address. It's albertiPhoneDeveloper@yahoo.com. And my website, as always, is www.decimology.com. I have tons of patterns there, so if you guys are watching this on another site, please, please, please come visit this and look at all the patterns I have and support me. And feel free to join. I'm adding a forum soon. It's depending on when you're watching this video, it might already be up, but you can post any patterns you have in there, or you can just email them to me, and I'm more than happy to give you credit. Again, that's my email, albertiPhoneDeveloper@yahoo.com. I hope this fascinated you, and I'll see you next time, guys. Thanks for watching.